All right.
Everyone not here for DevOps Bootcamp, you don't need to leave, but we're going to start doing some stuff.
That's totally cool. Am I in anybody's way over here?
No, definitely not. We're just gonna be like talking loud.
Yeah, let me know. It's pretty hard. Yeah, it's looking strange.
Says it's on. It looks like it's plugged in.
Yeah, well, I mean, yeah, obviously, like, yeah, they were.
It's like Simba. Like, all right, guys. We're just gonna get started. Welcome to DevOps Bootcamp. Today's lesson is on testing and software development. So has anyone actually taken software engineering? 1 or 2? Have you? Okay, cool. You'll go over a lot of this, kind of this stuff in this class, or in that class. But here we'll talk about like way more fun things than writing Java. So to provide a little bit of motivation for writing tests, how many of you guys have ever written a C++ or a C program and then you had to like compile it and like try it out with a couple different stuff and like took a while?
Who here took 161? Okay, so you've probably done the thing where like you wrote the program and you had some functions, maybe even a class, and every time you wanted to test it, you had to like compile the program, enter in some values, and scan it in, see what the output was, maybe grab a piece of paper, check the values. It sucks, and it took a really long time, but
you can write tests instead, which is just like, it's basically to say you can write a program that will automatically do all of that for you, which is pretty cool.
You write a program that uses your program and tells you how broken your program is, or not broken.
Well, usually broken.
Usually broken. Let's go.
So it can do lots of really nifty stuff. It can verify inputs and outputs. It can ensure that your program meets any requirements that you have. So it's especially important in like enterprise coding kind of stuff where you have a client and you want to be able to say like, look, my code does what I say it does. I promise. Really, this other code says so. It can respond correctly to inputs. It's usable. It can be installed in lots of different runtime, or not runtime environments, but just environments in general. So if you're writing something that needs to be compatible with Linux and Mac and Windows, then testing that is obviously kind of necessary. I know this is really, really little. Okay, I will click on it because it's pretty funny actually. Haha. How do I go back? So the joke here is that he's trying all these different kinds of. Okay, I don't want to explain the joke. Okay, so there's a couple different types of testing. One is static, which we kind of talked about earlier in the year when we talked about linters. So it's basically the same idea where static testing basically just goes through your code and checks for really common errors. So it's a little more than just syntactic errors. It's more stuff like, hey, I noticed you're using a global variable in your C program, and sometimes that's kind of a bad idea. Maybe you should rethink that. Stuff like that. It's kind of similar actually to the like when you compile something and it gives you all those errors. That's kind of ish in a way a form of static testing.
Another thing it might test for is, and this is sometimes covered by a linter and sometimes covered by a testing suite. But it might say something like, hey, you declared a variable and then never used it. Just letting you know, like that's the thing. If you have a variable and it's not used, maybe you get rid of it. So it doesn't run your code, so it doesn't actually experience the breaking. It just sort of looks at your code and says, this looks like something that usually breaks.
Yeah. And that's, static testing basically involves verification. So it's verifying the actual words in your program as opposed to, like Eli said, what your program is doing. On the other hand, dynamic testing actually runs your code and determines if the output for a given input is what you expect it to be, essentially.
Question.
Yeah.
What is an advantage of static testing over dynamic testing?
I don't know.
If I'm not mistaken, I believe it's way faster.
Oh.
Because it doesn't need to actually run your code.
Yeah.
And dynamic testing is great because it's real. It actually does the test.
There's one that I think should be on here, but it wasn't, I Googled for it, it wasn't a thing, which is human testing, which is how stupid proof is your code? So kind of like in the previous slide we saw actually, where like, it's easy to say, okay, given this input, what should be the output? But like, what happens when someone uses your code in a way that the code was not intended to be used?
Actually,
These are things to think about.
can I go on the tangent?
Yeah, go for it.
So Jordan and I were talking about mechanical Turks.
Oh yeah.
You know what a mechanical Turk is?
Mhm.
Basically like getting a bunch of people to do a robot job. Amazon does it. They have they basically have fleets of people, and they give them like a task, like, hey, listen to this audio file and report back whether the musician, whether the vocalist was male or female. Something really dumb and simple. Basically, like a company will pay Amazon, and Amazon will distribute money to all these people, and it's called a mechanical Turk program. And we were thinking, what if you had a mechanical Turk for like web apps for the same human testing thing, where it's
That'd
like
be awesome.
instead of using what's that web testing framework platform for like JavaScript?
Oh, Selenium?
Selenium, that's what it was. Instead of Selenium, you use human testing with mechanical Turk to see how accurate it is. I think it'd be a really fun project. I think we should organize that.
I'd be down. I think that'd be pretty effective actually.
Yeah.
So I feel like there's a lot of stuff that I just don't even think about as a
Right.
programmer. Of like, what if someone did this thing? So I'd be like, no one would do that.
Yeah, and they can report things that the computer doesn't quite notice. Like, I made a website where the like introduction text was way too small, and I just didn't even realize it because like how I had things configured.
Mhm.
But if a human person was like, "What's wrong?" If you're like, "What's wrong with this?" And I'd be like, "I can't read the text. You suck. Fix that." So it's not an official form of testing, but people testing is a thing.
Something to keep in mind. So does that kind of make sense to be? Yeah, pretty. Everyone's like, yeah, Lucy, duh, it makes sense. Move on.
That's pretty common in like the game industry.
Yeah.
We have testers.
No, it's true.
Yeah.
Games are actually one of the hardest things to test because of like, oh, you have a character interacting with a 3D world, and when you do this one thing, you jump 5 times, you do a backflip, and then you cast the spell, then the game crashes. And like, there's no way to test for that. One way of automating game testing that I've heard of is there's a game called No Man's Sky where basically you just fly to procedurally generated planets. The way of testing that was they had a spaceship fly over procedurally generated planets and generate an animated GIF of the surface of the planet, and then people would just watch the GIFs on like 10 times speed and just see how messed up it was or how beautiful it looked.
Say one
GIF.
more.
Huh?
Say one more.
It's a GIF.
Never heard GIF. Well, I have.
It's because it's controversy, and Eli was like, I'm going to step over the controversy and just call it something that nobody understands. For those of you listening at home, a GIF is just a GIF.
Yeah.
It's a GIF because the people who originally created it at CompuServe in 1987 actually named it after the peanut butter. I did a research project on
Technically, a
it.
GIF is not a GIF. A GIF is a static image. A GIF is an .gif image.
Oh, okay.
That's the distinction.
So how's this really testing again?
It's not. It's candid. People enjoy it.
Moving on. So there's also black box versus white box testing. And essentially the box refers to whether you know how the internal code is working. So white box testing is actually testing the internals of your code to make sure that it does what you want it to. Generally, it's like a programmer kind of, well, I guess a programmer is doing both of them, but like with the white box, it's you as a programmer unit testing all of the chunks of code that you just wrote.
And we'll define unit testing in a second.
Yeah, they're internal to the thing, whereas a black box is more of an end user interface way of testing, where you assume nothing about how the code actually works or how the application works, and you just see if it does what you want it to.
Yeah. So what would be an advantage of doing black box testing? Or why would you use black box testing instead of white box testing? I can tell you.
You're testing like your users, how they would be viewing the system basically. So like if you have a website that did a bunch of things to generate the HTML, white box testing would be actually testing how is it generating this HTML internally, all the functions to do that. Black box testing would be like, you're not really concerned with that thing, you're really just concerned with this function. put something into, in this case, you're requesting HTML, and what that gets back is that what the user wants to see. They don't know how it's being generated. That's not what you're testing. You're just testing that what you're getting back is what the user wants to get back to HTML.
Right, yeah, you don't care how the code generates, right? You just care what it's supposed to do. So you're always testing against the spec and less against the actual code.
Yeah.
This is good for like libraries when you don't have the source code.
There's also, oh, go ahead.
Yeah, or if you have like a lot of legacy code
Right.
that wasn't written to be tested,
Right.
black box testing is about the best you can do.
Yeah, pretty much.
There's also an idea called gray box testing, which it's a thing. It was on Wikipedia, which obviously makes it a thing.
Those are people's stories.
Which now I'm gonna forget what it actually was. I thought I was gonna be super smart.
Don't just do anything back.
Will you just Google it?
Yeah.
Thank you.
Google is also pink box testing.
There should be pink box testing. What would it be?
GameCube testing.
Gray box testing is a combination of white box and black box. Okay, we got
Wow.
that. The aim of this testing is to search for the defects, if any, due to improper structure or improper usage of applications. So I guess this would be more like Selenium side-ish. kind of.
Yeah, so I think the idea of gray box testing is how does my code react when people use it in a way that it wasn't intended. So black box is more like, does this behave how I expect it to?
Big fuzzy testing.
Whereas gray
Yes.
box, yeah,
Okay,
So,
so
Yeah.
gray box is fuzzy testing.
yeah.
more or less, yeah.
Oh, it makes sense because it's like gray, like static.
Right.
Oh.
It's basically, the aim of the testing is to search for the defects, if any, due to improper structure or improper usage of the applications.
Cool. Solve that.
All right, so there's kind of 3 levels of testing, for lack of a better word, and it's kind of like Lego blocks. So unit testing is testing like a single Lego or a single chunk of code. So it's saying like, I wrote one function and I'm going to test that function to make sure it does what I want it to. That's kind of the input-output stuff that we were. Integration testing tests how various Lego blocks fit together, essentially. So one example that I saw was, okay, I've programmed a keyboard and a mouse, and they both work separately, but do they work together? Like, do they interface properly together? If I do this thing, will one or the other of them break? That's basically integration testing. And then system testing or end-to-end testing is just the final product. It's when I put all of these components together, how does my entire system behave? Most of what you guys, at least in your undergraduate, will probably be doing is just unit testing. First of all, we don't do a whole lot of like really large scale systems. And it's also just like, obviously when you're building something out of Legos, you deal more with the individual Legos than the whole shebang. All right, unit testing. I know I actually just kind of talked about that. So it's probably not so kind of like I just explained, this is just testing like one chunk of code. Integration testing, how stuff fits together. I kind of like this graphic. Whenever I Google for images, I generally find a lot of like really businessy, PowerPoint circa 2003 kind of images. And this is one of them that I just really enjoyed. And then system level testing, like I said. So we were speculating earlier what the meaning of this text was. And if we actually look at how many different types of testing there are, we'll just go to Wikipedia. The most reliable internet source. Okay, so we can actually just see in the contents. There's a lot of different types of testing. So even though this is a pretty finite list, you'll note that there's a lot of things. And I think sort of the idea behind this graphic is just that like you're never really done testing. Sort of like a piece of art is never finished. You will never be able to verify every single part of your code and verify what it does. At least not with a large enough system.
Always be bugs, is what you're saying.
Yes, there will always be bugs.
You're going insane before you fully test your code.
Yeah.
If it's complex enough.
Yeah. Of course, if it's like a Hello World program, well, you can probably test most of that. But so one thing that we often use to make testing a lot easier is a testing framework. We've talked about frameworks a lot in here, so you guys probably already know what it is. In fact, Annie, can you tell me what a framework is? Haha. What about you, Ricker? Huh?
Oh,
Framework.
it's like a piece of code that you can call to help make stuff easier.
Yeah, that's actually it's just yet another word for, chunks of code that make your life easier. So in this case, usually it manifests itself in some really easy way to write a test. So usually there's like a decorator, like in Python, maybe it's an @ and then test. And then you'd have a function that's like, test this thing. And inside it, you would say, run this piece of code. And if the output is not this, then error out. And I think we have a couple examples of tests. And if not, then we will pull them up on the internet. But that's kind of the basic idea. The Python standard library has this thing called unittest, which may or may not be useful. That's just the one for Python. That's a really helpful slide. I didn't actually write this. Magical, do you know what mocking is?
Yes.
Go for it.
Is when you're testing things, sometimes they call functions that take a while or connect to the network or something. Let's study. Let's study. Anyway, parts of the system that are tightly integrated with other parts of the system, like a function that grabs a web page and does something with it, are to test because it goes and grabs the web page, and you don't really want to test that. You want to test what the function actually does with the web page. So you can mock out a function to
provide that response.
Yes.
So that you don't actually have to. Right. So basically what he's saying is like if your code relies on other code, but that code is really slow or you can't be 100% sure that it will do what you want it to, you can essentially kind of feed it fake inputs and then see how it reacts.
So like you provide a get URL function that just returns a static string.
Right.
And doesn't actually connect to them. And it's a way basically of isolating parts of the system from each other.
Yeah. So that kind of makes sense to people. Yeah, maybe. Cool. More things that we didn't actually write.
What's going on?
Huh?
Code went off the screen a little bit.
Yeah, I know. I did not actually write this, not to place blame on other people, but
First time we're doing it.
yeah.
We'll just think about mocking is if you're using it too much, you should probably reorganize your code so that you don't have to.
Yeah.
Probably is wrong.
Yeah.
So one thing that we've talked about before is automated testing or continuous integration. So can one of you guys tell me what continuous integration is?
It continually integrates.
Thank you, Spectral. Anyone? Bueller?
Like you run tests as soon as you make changes to your code, pretty much.
Yeah, it's basically a script that says like, hey, if this piece of code changes, or someone like on GitHub, you'll see if you submit a pull request, usually this thing called Travis CI, which I think we talked about during Continuous Integration Week, will just automatically run tests on it to verify that it does certain things. So that's kind of, Eli mentioned earlier the idea of a test suite. And a test suite is just a whole bunch of tests, and generally they will automatically run when some event happens. They are really useful because then, one, you don't have to like manually run tests every time you want your test to run. which would be pretty boring, I think. But another thing is, like I mentioned earlier, if people are contributing code to you and you want to verify that that code does a certain number of things, then this is a great way to do that without, again, having to have someone sitting there manually running tests. And I think that's the end of our slides. Yeah.
Can you vamp? I'm writing a demo.
Hmm?
Can you vamp or running a demo?
What is VAMP?
It's all right.
Do it, Dan, talk.
What do you guys want me to talk about?
Testing horror stories.
Do you have any?
Write tests before you write your code.
Oh, actually, I do have something to talk about. How many of you guys have heard of agile testing or extreme programming? Yes, no, maybe so.
Did it for a while.
Test-driven development maybe is something else that you've heard of. So the idea kind of behind all of those, well, so I'll start with test-driven development because it's the most basic of those. The idea is that you write your tests first so that you know what input you're expecting and what output you're expecting, and then you write your code in order to make those tests pass. Does that kind of make sense?
Why would you do that?
You would do that because then you can, well, one, then you get the hard part over with first. Like in general, writing tests is a lot less fun than writing actual code. So if you write the test first, then like the hard part's kind of over. Another thing is that then you can verify pretty much instantly if your code actually works or not before you move on to other things. So those are kind of motivations. It also really gives you a good idea of what you're expecting your code to do. So before you actually sit down and write, you want to maybe have a clear picture of what exactly it is that you want your code to do. And I know in stuff like CS161, it's like, well, I want this connect 4 name to go, and like that's easy. But in a larger system, sometimes it's a little harder to define exactly what you're trying to do. And tests can kind of help you do that. They're also kind of good for documentation, etc.
I actually look at writing your tests before writing a code, which is sort of what you're talking about, as like a more constructive version of writing out your program on paper. It's sort of like you have to really methodically plan what you're going to do before doing it, and that gives you a better idea of your actual goals, and also makes actually writing the code a little easier because you have a very concrete idea of what it's supposed to do. I've sat down and been like, I'm going to write a script that does X, and then 2 hours later I'm like, I have added 5 features over the past 30 minutes, and I have no idea what I'm doing anymore. But if I wrote tests beforehand, I would be like, here's the spec, I have tests, I can just write until all the tests pass, etc. That makes sense.
Yeah, and this is really common, like I said, in agile or extreme programming, which is kind of this like ideology that is part of your science, I guess, or like it's an ideology that motivates some programming. So
It can be part of agile development. A lot of agile development doesn't do that though, and that's why they have bad documentation and mediocre performance.
yeah, actually, so a lot of it, well, not to preach too much, but like one thing or one idea of agile software development is that your tests should be so good that they serve as documentation. So people should be able to look at your tests and kind of assess what your code is actually doing, which is kind of silly, especially if you don't actually have the running tests.
Not all tests make good documentation.
Right, and that's the problem.
Because testing mainly deals with edge cases. Like what happens if I feed this function infinity or 0 or whatever.
Right.
Whereas for documenting, you want to deal with the common case mainly.
Exactly, and I mean, they'll say like, oh, you can fill it in with comments, and like, people should be able to look at your code and know what it's doing also, and it's like, well, it's not always that easy. So that's kind of what the comment was. Does that make sense to people, test-driven development? Kind of, yeah.
One more advantage of writing your test first that I think is kind of interesting is that it kind of tests the tests. Because tests pretty much always succeed. You expect them to succeed, but you can write a math test that always succeeds and doesn't actually test the thing you're expecting to test.
Right. Yeah, you could write a test and then write a method, and then the test passes and you're like, great. And then you're like, let me try something, and like remove the method and the test still passes, and you're like, I don't know if that's what I wanted. Like the method's supposed to return some super advanced constructed tuple, and it ends up, you just, for fun, you just return true, and it still passes, and you're like, that's not what I wanted. Or, that's like an extreme case, but.
So making sure that the test is capable of both passing and failing. Make sure that your tests are good.
So does the necessity for tests make sense? Like, if nothing else, it's just convenient. It's also really nice because you can give someone else the test package and say, hey, download my library and then run these tests on your system. And if the tests pass, that means that your system is ready to use my library.
Tests are required as a programmer if you want to be able to sleep well that night.
Yeah, actually that's true, because otherwise.
It's proven.
Yeah, because
Stress levels go way down.
Because if you don't have tests, then there's always that daunting feeling of like, my code could break, and I don't really have any bearing on how
What's
solid
also
it is.
interesting is that usually people that aren't writing tests don't even have that knowledge that could happen. They're just like, I am the greatest man alive. I can do anything.
If you think you're the greatest programmer, you're not.
Yeah, and you need to write tests.
And you need to write tests.
Yeah, I was against it for a long time when I was a road coder. It's the way to do it, no matter how you're doing it. It's like, I just want to write the code and make it do it. I don't need to test it. I can write the code and it does the thing. And it's like, no. What if I give you that thing? What if I give you -1 items? And I'm like, oh, didn't think of that.
Yeah. Or if I give you lizard. How does that?
Then I think I made an e-commerce site that I didn't account for inventory, so people could buy stuff and it would say that the site owed you money. So it's like, that's why you write tests.
Yeah. So if there's money on the line, definitely write tests. I have a demo. Do you want to?
Go for it.
Okay. I need a terminal.
Do you need help or?
I need terminal and Python.
My rocket science paper.
Preferably just a new terminal. Like a full screen, pretty big.
Cool. Let me go get water.
Okay, so as a way of showing tests, I'm going to do a very basic demo, and we're going to mess with it a little bit. It's definitely not meant to show how awesome testing can be. It's just Python using Python's built-in unit test library. And honestly, I'm copying from an example I saw during Barcamp, which was not about testing. It was about Travis CI, which deals with testing and automated integration. But basically what we're going to do is we're going to write a really small function. What is it called? Adder.py. And we're just going to write a function, def add a comma b. Okay, and then what this does is it returns a plus b. So, and at the end, I'm just going to print out just so I can know, like, does this work? Does this do anything? So, but 8, which is good because I gave it 5 and 3, so it works. And this is how most people would test their code if they were not writing actual tests. They would just print a statement at the end or do something like that. But we're going to be awesome and write actual tests. And by the way, I'm opening this up with Vim, and bang $sign just means use the last argument of the previous command. So in that case, it's adder.py. Just in case that was confusing.
I can see the numbers.
What is it? Sure. What is that? Syntax.
Purple and black.
Cool. Is that good?
Yeah.
So we have our function, and we're going to include a library called unit test, which we'll look at the documentation in a second. But essentially, it's Python's built-in unit testing library, so you don't need to pip install it if you're using this. If you're writing Python, it's just included. You don't even need a virtual environment or anything. It's just there. You get it for free when you use Python.
Does it cost money?
Well, okay, yeah, it costs $5,000, but whatever. Like after that, it's free. That's a joke.
Standard Python.
When you buy Python.
When you buy Python, it's free. When you write tests, you can do it a few different ways. You can create a file for testing. One way that they actually suggest you do is you include the tests in the module that you're writing. So for adder.py, the file will both include the add function and the tests for the add function. It just makes it nice and it's like one big package. Not look good. So the way that we do this, I'm looking at my screen. We create a class, test add, and we include. We import unittest.testcase into the class. Oh, sorry, Harry. And you should name your test class something reasonable. Like, don't name it test buts. Name it something that actually makes sense.
Don't name it my test.
Huh?
Don't name it my test.
Yeah, also don't name it my tests. Or don't name it like hello test world, something like that. It should make sense. We don't need to make it self-documenting, but it would be nice if it made a little bit of sense. So in there.
The function with test prepended.
Huh?
Usually just the name of the thing you're testing with test prepended.
There you go. Yeah. So, and then this class's only job is to test this method. So if we had a subtraction function, if this is just a general math library, we would have test add and also test sub and test mul and test div for all of the different functions. So in here, we're going to define, basically we have this class, and in this class, we define our tests. So we're going to define test it works. And here's our first test. Basically what it's doing is it's saying, we're saying test that it works, which is just the name of this function. It's just going to run this function. And we're making an assert statement, which is basically we're saying, is this true? Or like, I want to say this is true. And if it isn't true, then this test fails. So if you add 1 and 2, it should be 3. That's what we're saying. And if that statement is true, the test passes. If that statement is false, the test fails. So that's cool. So we're going to run Python adder.py. We don't get any output because we didn't print. But if we ran Python test adder.py, whoa. Is that not how you do it? What's the?
You could probably do Python.m unit test.
That's what?
-m unit test.
Oh, I know what it is. I forgot something. You also have to include, sorry. You also have to include this at the end if and this is kind of just janky Python stuff. I just usually don't include it, and then a tutorial tells me I need to include it, and I do.
So basically what that's doing is the double underscores are basically saying like, this is something that is special. Like there's no really good Python.
Yeah, you just rot memorization to get all of these in your head.
They just are.
They just are. Like, underscore, deal with it, underscore.
Yeah, like one time I asked someone like, what does this actually mean? Or like, why is it here? And they're like, it's magic and I can't explain it. So basically it's saying like, when I call this file with Python, this is the first thing I want you to do. So like that is kind of like name in a C or C++ file. How like when you run it, that's the first place it looks. That's kind of your Python name, essentially.
So that's going to run first.
Yeah.
First,
I
it's
thought
going
it was
to run the thing that defines the function.
I mean, it's a script, so like it's going to just go down
You
iteratively.
could,
But
so you could just put unittest.main at the end of the file without the if, and that would work. That would run fine. But the reason you add the if name equals main is so that if you import this module, it won't run.
That's only when you run it directly.
Yeah.
Right.
I remember this for like these.
So like I said, this is really good for libraries. if you were just testing this library and you're not actually using what's in the library, it will run the tests and only the tests. Like that's all it's going to do. But if you wanted to like import add into a a library or a function or a program you were using or writing, it wouldn't run this test. It would just use your add function. So it's convenient because basically it's saying if adder.py is the thing that Python's running and it's not being imported into another module, do this. Otherwise, do whatever you want. Does that make sense?
Yeah, I saw that in the, what's it called?
That's
The
the
best
best.
burger once.
Yeah, it's used in Flask. Similar things are used in Flask and stuff,
Python's idiom.
pretty much. So we're gonna write and quit, and then
When we run Python adder.py, this dot means it did a test. So if we had 10 tests, there would be 10 dots or not dots if they fail. And then at the bottom it says we ran one test in 0.000 seconds because it's a very quick test and very fast.
You make it down.
yeah, we can. So
How do you know the test actually works?
how do I know the test works?
Yeah.
What do you mean?
How do you know that it's passed, but what does that mean?
We haven't seen it fail.
Oh yeah, no, you're right. I just wanted to show the success before we show the failure.
Well, I mean, you can do a test that you know is gonna fail.
Dude, I wanted to show success before I showed failure.
I know, but you don't have to.
We're doing it right now. We're showing
No,
failure.
you don't need to change the original function. You just write a new test that will fail.
We will also write a failure test.
I'm chill.
You're the opposite of chill.
I think you're the one that's doing it.
So
I'm gonna steal this joke. I don't like pluses. I think that they mess up the code. I'm much more into stylistically dashes. So we're gonna make this a negative sign instead.
So
Joke.
what?
So there was a joke, something.
Yeah.
I think it looks way better.
I think the joke is that there was no joke.
That's not funny.
What? Yes, it is.
I'm not
Wait, don't get into it.
So, as the good programmer or bad programmer I am, I made my stylistic change and then I pushed it to production. Someone cloned my repo. They ran my test and they saw the giant F, and my code failed and it spat out and it just vomited everywhere.
So someone pings me and they're like, dude, your git commit said style change and it broke everything. And I'm like, fine, let's make this work. Okay, well, let's see. Negative. Whoa. Your page down is right next to your down arrow.
Sorry.
Okay, well, let's make this.
Way to go, Lucy, for designing such a shitty keyboard. What are you in college for anyway? Like, hang out? Like, you learn anything?
What? Hey, why would that fail?
Because the B is
negative one.
Oh. Yeah, we're good.
Oh, bro.
We're good. We're good.
Now you have too many parentheses.
You have too many parentheses.
And I think it'll also be -3 now.
Wait, how do I make this pass?
-1 minus 2 is -3.
How do I make this pass?
Just do A plus B.
Put the function back to how it is.
Fine, fine.
Oh, yeah, it would be.
Yeah, you have a negative on the wrong side. He's right. There, it doesn't cancel out. Look at this guy.
Hey, our test pass. Kinda. So that's cool. We're gonna undo our style change. The person that ran the project was like, dude, you're messing up my math library. I had one job and you broke it. So we're gonna write another test because clearly this is not well tested enough. I realized that we haven't tested for like negative inputs. Obviously it works with 1 + 2, but what if it works with, or what if it doesn't work with like 1 - 2? So we're gonna just try that. 1, 2. And that should be, what if we don't know how to do math? We just say 3. What happens then? Oh, hey,
One test passed, and one test failed. So
we have to fix,
Hey, chill out, man.
Hey, you chill out. -1. So now we have 2 tests that pass. We know based on a failure that it's doing tests, kind of, and we have 2 passes, and that's good, right?
Yeah.
Any questions?
Did you explain why test it works with a big name for a test method?
Trick question. What do you think we should call it?
Test addition. Or test 1 plus 2. Or
Yeah. That's one.
you're going to test.
Test positive.
That worked.
Yeah?
Yeah.
Why is that bad?
I think it's because it can apply to a lot of things. Is kind of what Magical's getting at.
Positive plus one.
Told you he knows.
You plus.
What Magical?
Plus- So the second test is positive plus negative.
What?
The second test is positive plus negative.
Yeah, test negative inputs, and then we can try.
So you can fill it out.
I think the point here is testing function names can get pretty long.
Yeah, because you're never gonna call them, so they should be descriptive.
Right.
Rather than.
Yeah, you don't need to worry about a programmer's interface with this, because like you and the people that are also working on test function, the test infrastructure, care about what this is, and there might be some internal documentation with your project on what each of these is. But for the most part, testing kind of just is self-explanatory. Like, not that you should just assume that. You should also write, documentation for this kind of thing. But like test negative inputs means, okay, well, we're testing only negative inputs. Take test negative input means we're testing a negative input, awesome. And then test positive inputs is just positive. So it can be long because like tens of thousands of people aren't going to be like, why is this function called test negative input? It could be called.
So yeah, it's gonna show up when your test fails.
Huh?
The name of the function.
Right, they're also going to show up when the test fails. So it would be really nice if your function name was super unique, so that when someone says, "Hey, I ran your tests and they failed," copy paste the output of the failure. It can actually like make sense to you as the programmer. The person might be like, "Oh, the test negative inputs test failed." Obviously, so here's this program. Yay. What happens if we do this?
Any questions?
I'm not trying something out.
Lucy, how many years did you graduate?
Oh, I haven't graduated yet.
It's 4 years to graduate.
Oh, wait, what?
Like 4 years, 5 years,
Oh, 3 actually.
and 3 years?
Yeah.
3 years, 4 years total.
No, like I'm gonna graduate next year.
How? Did you have a lot of credit coming in?
Yeah.
So this is what happens if you try to call a function that doesn't exist. Like I tried to call the neg function for like negation.
Whoa.
And it gives out what?
It's an
Cool
E.
function, bro.
So it's an E instead of an F, which means it's an error, not a failure. So that's interesting. Any other questions? We can look at the documentation you guys want, or not.
Where are your tests?
My tests?
Yeah, your tests.
They're in here.
Your
They're in here.
response.
I'm actually still here programming and
Really? So let's start off the build-in and test like the actually testing. I don't know how we come back to that.
Any-
That would be an integration test, how you well you integrate into the ground at a high velocity.
Are there any questions on like things that we want to look up? Like, hey, can you do this with that? We can look up documentation if you guys want.
Can you test dogs with cats?
I can do that right now.
It's had to because it rhymed and you have a cat shirt on.
I do have a cat bar camp shirt. You're right.
I love to meet some dogs and cats.
and replace. Okay, that's it.
Yay.
Woo.
Thank you guys for coming.
You want to talk about Docker?
Thank you
Talk about
for.
Docker, yeah.
All right.
Talk about Docker.
So configuration, I guess.
Boop.